Hi, and welcome to day one of rational expressions. On your own or with a partner, write two fractions that are equivalent to 1/3 and use the slips of paper to create visual models to justify your response. Well, since you're on your own and we don't have slips of paper, we're just going to draw pictures to represent a fraction 1/3. So if I draw a box and I split it into thirds and I color in one section here, this is 1/3. If I take that same box and I split it into thirds again and I color in my 1/3, I can add a little bit more to this box and I can split it in half that way. So now this box really represents 2/6 because I have 2 out of 6 blocks colored in. Then I could go back to my original box, color in my 1/3, and instead of splitting in half, I can split it into thirds. So this is really 3/9 because 3 out of the 9 boxes are colored in. But by looking at your picture, you could see that 1/3 is equivalent to 2/6, which is equivalent to 3/9. So what we're going to be doing is dealing with fractions that are equivalent, and we're going to be reducing our fractions. So for example 1, consider the following rational expression: 2 times the quantity a minus 1 minus 2. Turn to your neighbor and discuss the following. For what values of a is the expression undefined? Well, we kind of have to go back a little bit to think about what undefined means. Undefined is when we have a 0 in the denominator because we're not allowed to divide by 0. So I don't really care what's going on in the numerator. So I kind of ignore that. We can kind of pretend like that's not there for this problem. And I'm just going to take that denominator, 6 times the quantity a minus 1 minus 3a, and set it equal to 0. Because that's really what I'm looking for, is that number that will make that denominator 0. So if I distribute my 6, I'll have 6a minus 6 minus 3a equals 0. 6a minus 3a is 3a when I combine my terms, minus 6 equals 0. Add 6 to both sides. So 3a equals 6. Divide both sides by 3. So a equals 2. So what that means is when a is equal to 2, then my fraction is undefined because I will have a 0 in my denominator. So when they ever ask you when a fraction is undefined, meaningless, or has no value, it's when the denominator is equal to 0. All right, flipping the page over. Exercise 1 is reduce the following rational expressions to lowest terms and identify the values of the variable or variables that might be excluded to prevent the division by 0. So initially in this first problem, it looks kind of ugly. People might just want to go ahead and cancel out those x plus 1s, but you can't do that because of this plus 2 up here on the top and the minus 1 on the bottom. These are individual terms, and we can't just cross off parts that don't belong. So what I'm going to do is just multiply. So I'm going to have 2x plus 2 plus 2 in the numerator. And in the bottom, if you need to, you can go off to the side and do your box method. 2x and 3 and x and 1. And when I do that, I end up with 2x to the second plus 5x and plus 3. And then my minus 1. So if I clean my numerator up, I have 2x plus 4 over 2x squared plus 5x plus 2. What we need to do now is factor and then cancel. So I factor my numerator, and they each have a 2 in common, and I'm left with x plus 2 over, if I factor my denominator, again, if you have to off to the side do your factor by grouping, you will get 2x plus 1 and an x plus 2. Now that I'm completely factored, I cross off the x plus 2, the x plus 2, because they cancel out, because I can only cancel out factors, not individual terms. So what I'm left with is 2 over 2x plus 1. Okay? Now what people try to do is then cancel out the 2's, but again, you can't do that because those are individual terms at 2x plus 1. Those are like a married couple, and you can't go ahead and cancel from a married couple. You can't break them up. That's not okay. That's what we call home wrecking. Now it said what values would give us a 0. So I need to take my denominator and say 2x plus 1, set it equal to 0, and I'd get x equals a negative 1/2. And then I have to go back to that x plus 2 and set that equal to 0 as well. So x equals negative 2. So x equals negative 1/2 and x equals 2. So this would be reduced, and they'll say for x not equal to 1/2 and x not equal to negative 2, that will be defined. For letter B, I don't have anything special going on other than the fact that I need to factor. I have to look for factors of 6 that subtract to give me 1. And my factors of 6 that subtract to give me 1 are 2 and 3. Larger number takes the sign in the middle, so it's minus 3 plus 2 over 5x squared plus 10x. I have a GCF of 5x. And when I factor that out, I'm left with x plus 2. So now this x plus 2 cancels out with this x plus 2, and I'm left with x minus 3 over 5x. Again, you cannot cancel those x's out. And this is true for x not equal to, well, the x plus 2 equals 0 will be equal to x equals negative 2. So as long as x is not equal to negative 2, and we have to set the 5x equal to 0, 5, not an 8. If I divide by 5, x is equal to 0. So x cannot be equal to 0 for our answer. Looking for what values make it undefined. For letter C, we have 3 minus x over x squared minus 9. What I'm going to do in the numerator is factor out a negative 1 so that my variables are all in the front. So what I'm going to do is switch the order. So I have negative x plus 3 over in my denominator. I factor that out of x plus 3, x minus 3, because that's a difference of two perfect squares. Nothing is exact, so I can't cancel anything out. So I'm going to factor out a negative 1 in the numerator. So I have negative 1. And if I factor out negative 1, I have x minus 3 because it changes signs. And then x plus 3, x minus 3. So now they both have an x minus 3 in common that I can cancel out, and I'm left with negative 1 over x plus 3. For x cannot be equal to looking at my denominator, I can't have a negative 3 and I can't have a positive 3. Negative 3 will make that one 0. Positive 3 will make that one 0. So to make it easier for us, I write plus or minus 3. This whole factoring out a negative 1 that we did in the numerator here is going to be something that's going to end up being very helpful to us as we go along. So let's look at the next question. In my numerator, they have a GCF of 3. So I have 3 parentheses x minus y over, well, this one looks kind of crazy, but the only way I can make y squared is with y, and the only way I can make x squared is with x and x. And if my last sign is positive, that means my signs are the same, and they take the sign in the middle, so they're both negative. Still, nothing matches exactly. However, if I look very carefully here, with this and just one of those, because they are the same, x minus y is the exact opposite. The x and the y have switched places here, with down here, and my sign is negative. So in the bottom fraction, I have a negative, so in the denominator I have a positive y and a negative x, where in the numerator I have a positive x and a negative y. So if I factor out a negative 1, so it'll give me negative 3, I can switch the order and make it y minus x. And then I would have y minus x and y minus x. So now one of my y minus x's can go out with one of my other y minus x's, and I'm left with negative 3. That's a 3. They like to connect sometimes if I write too fast. Over y minus x. And we're just going to say for x not equal to y, because that's the only way this can be 0. So if I do y minus x equals 0, I add x to both sides, y equals x. So that's why x cannot equal y, because that's the only time I would get 0 in my denominator. So this negative 1, factoring out a negative 1, is going to end up being a very important thing that we need to look for when we are factoring. All right, until next time.